So the first thing that you have to establish is how many pieces of pizza, right? 8 pieces of pizza, right? Okay. If there are 8 pieces, what is the central angle? 45 degrees? Okay. For one piece, right? Alright. Can I use 45 degrees?
No.
Why not? Need it in radians. Okay? So then we gotta convert 45 degrees into radians. Anybody? Okay. Does it reduce? To what? Pi over 4. Okay. So a piece of pizza looks like that, correct? Okay. We know what? Radius is 14. So this side is 14 inches. This side is 14 inches. What's the arc? Seven pi over 2. Yeah. Okay. All right. So what's perimeter? I'm just trying to find the perimeter of our one piece of pizza. It's not 11 though.
It's 28 plus 7 pi.
7 pi over 2. So the perimeter then is going to be 28 plus 7 pi over 2 inches. Agree? Questions, comments, concerns, clarifications on some cases that are not necessarily showing complete agreement? Because there was 8 pieces, right? So if I take my circle and I divide it into 8 pieces, right? Right? That would be 360 divided by 8, which is 45. Then convert that to radians. Well, because we have 2 radii, yes. That's the only reason why we added a diameter. Good? Okay. Right. Love it. Mrs. Hill is cruising on her new electric scooter at its maximum speed of 15.5 miles an hour around the mean streets of the Saw. At this speed, how many revolutions per minute are the 8.5-inch diameter wheels taking their roads? Okay. Go for it. Yes. Right? Should this be a really large number or a really small number?
In the hundreds, right?
It should be large, shouldn't it? Because if we're traveling at 15.5 miles per hour and the little teeny tiny wheels, that means that those suckers are spinning pretty fast, right? Okay? Right? So, we know for a fact at the start, we be traveling, or I shouldn't say we, Mrs. Hill be traveling at 15.5 miles per hour. We know that. That's the start. Okay? We want revolutions per minute. Round and round we go. Okay? First conversion. Hours to minutes. So somewhere along the line, you should have a 1 hour over 60 minute fraction. Okay? So now I'm in miles per minute. Feet. (5,280 feet). Next one. Inches. Inches per minute. Inches to radians. What is the radian? 4.25. How?
There is one revolution every 2 pi.
Should be left with only revolutions per minute. Yes? Okay. So on top, I've got 15.5 times 5,280 times 12. On the bottom, I've got 60 times 4.25 times 2 pi. Zero. 60 4.25 2. I get 612.952 RPMs. Yes? Okay. Gotta be careful how we're typing things in. Okay. Again, I mentioned this yesterday. If we're typing this in as is, that whole denominator's got to be in a set of parentheses. Otherwise, it's only going to divide by the first number and then multiply by everything else after that. Your number's going to get ginormous real fast. Okay? Love it. Oh yeah. The belt on an electric motor connects metal wheels with a radii of 2 inches and 5 inches. The rotational speed of the larger wheel is 120 RPMs. Fine. Angular speed of the larger wheel, linear speed of the belt, angular speed of the smaller wheel. Anything else we got going on here? Nope, just those 3. Ooh, yeah. Ooh, yeah. So what do we know right from the start? Okay, the radii and per minute. Okay, of what? The larger wheel, right? So we got the RPMs of the larger wheel. 120. We want the angular speed of the larger wheel. What do we do? We're now in radians per minute. Got to change it to seconds, because it said we wanted it in radians per second. So 1 minute is 60 seconds. Radians per second, yes? Okay, so that would be what? 120 divided by 60 is 2 times 2 pi is 4 pi radians per second. Yes?
You want it left in that form?
Does that make sense? 120 revolutions per minute means how many times is it going around per second? 120 revolutions per minute means how many times is it going around per second?
I got 12.56.
Abby, what do you got? 2. It's going around twice per second. Right? 120 revolutions in 60 seconds is 2 revolutions per second. Right? 4 pi radians per second. How many revolutions is that per second? 2. It's got to be the same, right? Because 2 pi is 1 revolution. Okay, so it's going around, so it's traveling at the same speed. So we're good there. Okay? If you would have rounded, okay, which I wouldn't recommend because there were more questions to come along with this. $12.566. Okay. So that whole wheel is turning at 2 revolutions per second, right? The big wheel. We now want to know what the speed of the belt is. Where's the belt attached to? But where? Where's the belt attached? The outsides of both of them, right? Okay? That's important because the farther you are away from the center, the different your speed is. Okay? So it's attached to the outside. Okay? So the center of that circle is spinning around, or the entire wheel, I should say, is spinning around at 4 pi radians per second. We want to convert that into inches per second. Okay? What's my first conversion? Okay, how?
When you take so you would go, what I did is there's 5 inches in every 1 radian.
5 inches in every 1 radian? Is that the speed of the belt? Yay or nay?
No, because the smaller wheel would also turn the same rate.
Not necessarily.
And don't we need to calculate that rate?
Oh, wait, that comes in around the speed around it and put it in the little one.
The what is going the same speed? The belt is going the same speed. Is that the speed of the belt? Yes. Yes, that's the speed of the belt. Okay? And the belt is going the same. It's not going faster around the smaller one and slower around the bigger one. The belt is traveling at the exact same speed around both of them. Okay? It's what's connecting both. So this gets me 20 pi inches per second, which is approximately 62.832. I didn't know. Okay. What is the angular speed of the smaller wheel in radians per second? What is the only speed that you know of the smaller wheel? The linear speed of the belt, right? Because the belt is connected to the smaller wheel. So the smaller wheel is also spinning at 20 pi inches per second. Okay? What is the radius of the smaller wheel? 2 inches. So the angular speed of the smaller wheel is 10 pi radians per second. Yes? Okay. On pulley problems like this, chain sprockets problems, when you're like bike riding type 1, the only thing that's connecting the two circles is whatever is connecting them. Okay? So the belt or the chain or the rope or whatever you have to find the linear speed of that, because that is the one constant between the two. Angular and rotational speeds are different because they're different size. If they were the same size, it'd be the same. Okay? Because they're different size, those two are different, but the linear speed is still the same on the outside. Linear speed changes the farther you get away from the center of your circle. Okay? Questions, comments, concerns, clarifications? Okay? We handed out a packet for you today. You should have picked it up when you came in. Okay? That brings you to a total of 3 yellow sheets. Okay? With the gold formative, that brings you up to a total of 4 things that will be due next week, Tuesday, which is the day of your test. Whenever. them and don't want to lose them, turn them in. Everything, with the exception of the one that you picked up today, is online. Actually, and today I think it's actually a 2-worksheeter. There's a 4.1b and a review in there too. So yeah, all of those, all that stuff is due Tuesday.